Have you ever just stared up at the night sky and wondered, how do we even begin to understand what's out there? I mean, how do we, on this one little planet, make sense of the entire universe? Well, that's what we're diving into today. It all kind of starts with a riddle, a real paradox. Think about that amazing image of a black hole we've all seen, that glowing ring of fire. It's awesome, right? But it raises a huge question. If a black hole's whole deal is that nothing, not even light, can escape, how in the world did we take a picture of it?
And that's really the heart of the matter. It goes way beyond just black holes. So much of the universe is completely hidden from us, working in ways that our eyes and ears were just never built to detect.
And here's the answer. It's brilliant. We didn't just build bigger telescopes, we invented entirely new senses. We've literally taught ourselves to see, hear, and even feel the cosmos in ways that are just mind-blowing.
Okay, so let's start with the one we know best, sight. For decades, our eyes in space have been sending back these incredible, vibrant pictures that have completely shaped how we see the universe.
And when it comes to sight, we've got a couple of heavy hitters. First, you've got the Hubble Space Telescope, the legend. For more than 30 years, it's been capturing the universe in visible light, the same kind of light our eyes see, giving us those jaw-dropping, iconic images. But then comes the new kid on the block, the James Webb Space Telescope. Think of it as the infrared detective. It doesn't see light, it sees heat.
And this is where it gets really cool. Picture a giant, dark cloud of cosmic dust out in space. To Hubble, that cloud is basically a brick wall. It can't see what's on the other side. But for Webb, with its infrared vision, that dust is almost see-through. It can peer right inside and see the baby stars being born. It's basically like having X-ray vision for the cosmos.
And, our best eyes aren't all in space. Down here on the ground, we have giants. The Very Large Telescope in Chile, for example, is actually 4 huge telescopes that can work together to get unbelievably sharp images. And get this, we're building the Extremely Large Telescope right now. Its main mirror is going to be 39 meters across. It's going to be a total game changer.
But seeing is only part of the story. A huge chunk of the universe doesn't really shine. It sort of hums in radio waves. So to perceive that, we had to invent a cosmic sense of hearing.
And that's where radio telescopes come in. These are our cosmic ears. Instead of mirrors, they've got these massive dishes that catch long, low-energy radio waves. They pick up stuff our regular telescopes would miss completely, like giant clouds of cold gas that are going to form stars someday, or even the faint leftover whisper from the Big Bang itself. And some of these ears are incredible. There's ALMA, which is like an army of 66 dishes all listening together for the building blocks of planets. And then there's the Event Horizon Telescope. This is it. This is how we solved that black hole riddle from the beginning. It's not one telescope. It's a whole network of them all over the world, linked up to act like a single telescope as big as the Earth. They didn't see the black hole. They saw its shadow against the glowing hot gas swirling around it. Absolutely brilliant.
All right, so we can see the universe and we can hear it. But what if I told you that now we can feel it? We've actually created a sense that can detect ripples in the fabric of reality itself.
We're talking about gravitational waves. Now, these aren't light or sound moving through space. They are literal ripples in space-time. Einstein predicted them a century ago. They're created by the most violent events you can possibly imagine, like 2 massive black holes smashing into each other.
So how do you feel that with this unbelievably clever instrument called LIGO? Okay, try to picture this. Lasers are shot down these miles-long tubes set up in an L shape. They bounce off mirrors and come back so perfectly that they completely cancel each other out, leaving nothing. But then a gravitational wave passes through Earth. It stretches one of those arms just the tiny, tiny bit. That tiny stretch is enough to knock the lasers out of sync. Suddenly, they don't cancel out anymore. And a little flicker of light hits a detector. And when I say tiny, I mean a change that is 1/10,000th the width of a proton. It's just an absurdly precise measurement, letting us feel a cosmic collision that happened billions of years ago. Okay, if feeling space-time wasn't weird enough for you, our next sense is basically a ghost trap. Seriously, we've built detectors to catch one of the slipperiest, most mysterious particles in the entire universe. Meet the neutrino. They're called ghost particles for a reason. There are literally trillions of them passing through you right now, and they don't interact with anything. They can fly through the entire Earth like it's not even there. But
They're created in the most violent explosions in the universe, and they travel in a perfectly straight line, which means they act like perfect messengers, pointing right back to where they came from.
So how on earth do you catch a ghost? You build a massive trap. Deep in the ice at the South Pole, there's a detector called IceCube. It's a full cubic kilometer of ice filled with thousands of sensors. The ice itself is the trap. On the super rare chance that a high-energy neutrino actually hits an atom in the ice, it creates a tiny flash of blue light, and the sensors see it. We're using a chunk of Antarctica to catch a single particle. It's wild.
So, we've got eyes, ears, a sense of touch for space-time, and these crazy ghost traps. Why do we need all of this? Well, because each sense only gives us one little piece of the story. To really understand what's happening out there, you have to use them all at once. It's a field called multi-messenger astronomy.
The best way to think about it is like this. Imagine the universe is a giant concert, but it's happening in a completely pitch-black stadium. If you only have one of your senses, you're going to miss most of the show. Our optical telescopes, our eyes, are like having a flashlight that lets you see the musicians on stage for a second. Our radio telescopes, our ears, are like hearing the quiet hum of the amps before the band starts playing. And the gravitational wave detectors? Well, that's like feeling the deep bass from the subwoofers vibrating right through your chest. You need all of it to really get what's going on.
And here's a cool little bonus for all this effort. It turns out that some of the math that was developed to clean up faint radio signals from space, well, that's the very same technology that makes the Wi-Fi in your house work. Kind of neat, right?
And we are far from done inventing new senses. The future is looking even more amazing. The extremely large telescope will be able to actually study the air on planets like ours, looking for signs of life. A future space mission called LISA will listen for gravitational waves from the very first supermassive black holes. And the big one, the Habitable Worlds Observatory, is being designed to do one thing: find another Earth with oxygen and water, and maybe, just maybe, finally answer the question, are we alone?
It's really an incredible journey when you think about it. In just a couple of generations, we've gone from just looking at the lights in the sky to listening to the echoes of the Big Bang and feeling the universe shake. We've built a whole new set of senses for our entire planet.
Every single time we've invented a new way to perceive the cosmos, it's shown us a universe that's weirder and more wonderful than we ever could have guessed. Which just makes you wonder, doesn't it? What's still out there, totally invisible to us right now, just waiting for us to invent our next cosmic sense?